Welcome to part 2 of L-RGB combination and calibration. Okay, so in the first part we corrected all the luminance and our RGB with linear fit, made a whole bunch of other adjustments and got them ready, combined as now a final luminance from your filter wheel, a final RGB from your filter wheel, and now we need to work on them separately like you normally do with one-shot color. So now let's always work on color first. I'm going to do it two different ways. This one I've renamed it M81 RGB color calibration as we would normally do, and you guys have watched part 1 to part 12. If you have, then this is normal because the next few steps you've already done them. The other one, this is just a clone, but this one's RGB photometric calibration. Let's see what happens between the both, and you can use either one, whichever you feel comfortable with. Let's get started. First thing, we're going to need to neutralize the background. It's always the case. So let's zoom in, find a spot where there's no stars if you can. Doesn't take a big area, and some of the Milky Way, they're so packed I don't even know where you can find a spot that has no stars, but that's what it is. And also, I'm going to show you a trick, something I never done on all my videos, and we're going to do now. So using the Alt-N, which actually all it does is create a preview. Watch Alt-N, and I want you to select stars. Here's one, Alt-N, bunch of stars, Alt-N. Whoops, don't think I'm pushing the right number here. Alt-N. So just keep grabbing lots of stars. The more there is, the more Pixinsight can make a calculation on neutralizing those star color. That's pretty close right there. Okay, so you can say, well, how do we fit all these in? Let's open up color calibration. It can only take one image, and I've got what, like a billion. Remember, 1 is the background, but 2, 3, 4, 5, 6, all the way up to whatever I have here, 14 is white. So here's the trick, if I can remember how to do this. Script, utilities, we're going to aggregate the previews. So using the preview aggregator 02, notice that all of these previews have been selected. Unselect preview 1. Why? Because it is the background. We don't want that. 2 onwards is good, but 1 is going to be used down here for a background reference. The rest, 2 to number 14, are white. So if you say OK, it's going to create. Oh, don't forget to click Create Preview. So let's do this. So there are all the stars aggregated into one preview pane. Now if you want, well, you don't have to, it's already called aggregator. So minimize this, just put it down here for a moment. Okay, let's go to the reference preview 1 first. So let's do the background. So preview 1, which is down here, that'll be the background. Oh, and another thing. Let's go back to preview 1 for a moment and open this up. You see all these lists here? If you had 10 or 12 galaxies and nebulas open up in window 1, 2, 3, and 4, this would be a mess. So try to stay with just luminance and RGB and close all the other windows if you can. Now let's go to the white reference, and instead of selecting all these, we're going to get aggregated. See here, aggregated. Oh, sorry, let me check that. Aggregated. By the way, this preview, I'm sure we can. I think we can remove that. Shouldn't hurt anything. There we go, aggregated. So aggregated is a combination of all, excuse me, let's put this over here, all these white stars in there. Now, some people disable structure because sometimes some people choose the entire galaxy, and you want to ignore the structure to just get the stars. So structure detection, I'm going to leave it on. Normally leave it on, but I suppose you could click it off. Let's see what happens now with our image with the stars to be neutralized and the background. Drag and drop. Yeah, well, let's see if something happened here. Aggregator, aggregated. I think I removed, did I accidentally, oh, right here. Sorry, we have to choose preview 1. Why? Because this is the background here. Okay, let's try it again. This better work. Yeah, it's working now. Detecting structure and applying color calibration there. And again, it always is so subtle, you can barely see any difference. But let's see if we zoom in here on some stars that were selected. And if you hover over here, it says undo color calibration, redo, undo, redo. Boy, oh boy, I'll tell you. Undo. If anything, this is just this particular star, which is a yellow star, just went a little bit fainter, and was adjusted. And another thing you can do as you go along here is open up curves, choose saturation, open a preview, and crank it until you can't stand what it looks like. So there it is. White stars, white, yellow. That's all proper. And ignore all this. This is just part of 1,000 times multiplication of the color. But it was a good idea to do this. In fact, I encourage you to do that. Always go to the max and always come back to normal. So close this. Now let's remove all these previews. Preview, delete all. We don't need them right now. Okay, let's shake this a bit. Got computer problems. Okay. So that neutralizes the background and it color calibrates the stars, and they should be good. Now there's a bit of gradient happening on here on the right and on the left. The one on the right is kind of red. The one on the left is kind of green. So a couple of things here you can do. Some people just use the green cast remover to make everything more or less a reddish blue, and there's no green in the galaxy. There's no green in space. But it's another thing I do. Let's just open up. If I got it here somewhere, I'll just reopen it. Looks like I closed it. So process, all process, dynamic background extraction. We're going to do it automatically this time. Make sure to subtract and replace target. I don't want to change the name of this. Okay, so first undo, redo. And let's drag and drop this and let's see what it pulls out. There should be some green and some purple. Well, I guess it's kind of lilac-ish. All right, let's have a look. See if we're doing our job right. There's your dark brownish green, and here's your purplish, whatever color that is. So that was a good idea. Close. Close. We zoom in. Everything is smooth now. But there's still quite a bit of green left. A little bit of green left. The corners are a little bit vignette. Not a big deal. But let's see if we can... oh, again, before we do this, these videos are going to be long. Re-choose your galaxy, go back to saturation, do the check mark for track, and bring this way up. Look at how much better that is. Okay? So we're going to leave this open for a moment because I want to go back to this. Move this down here for a moment. Let's remove the green cast using that little guy. Where is he? Again, I closed them off. So process, all process. Starts with an S. SCNR. So SCNR at 100% to remove all this green that doesn't exist in the black of space. Okay, so everything's turned kind of purple. Don't think I'll use this again. But I'm going to go back up here. Check out the preview. Now it should be a lot. There should be a lot more purple now. Yep, and the stars are still yellow. The galaxy still has a nice blue tinge to it with a yellow center, which is what M81 actually looks like in reality. Reset, close, remove the real-time preview, and here we are. So again, undo, redo. Sometimes that really accentuates things. Yeah, what do we got here? Make sure this is still matching. It is. Yeah, we're developing some kind of a circle here, which is why I really never liked using dynamic background extraction. Then automatic background extraction. I usually split RGB, clean them up and put them back together as one, but I'm following some of the books that I've read and other people that I've watched, other information. So, but you get the point here. This may not even show up once the luminance channel's on top, so don't worry about that. So now, a little bit of noise reduction, multi-linear transformation. Let me see if I can find that here. Multi-linear. I've got multi-scale. Don't know if a multi. Yeah, I don't want multi-scale. Let me try to find multi-linear transform. Don't use that one too often. Right here. Okay. So multi-linear transform, you can use that, but you're going to need to create a range mask. Why? Because we're going to try to cover as much of the galaxy to the edge, and then we're going to invert it to just attack the background. In fact, if you zoom in here, that's not that bad. If we do any type of denoising, it's going to have to be very, very little. Might even have an icon already made, but let's go from scratch. So this is going to end up being, okay, as I said before, we need a mask. Remember there's two ways to make a mask. You can extract luminance and then stretch it and drop it on. That's one way. The other way is to use range, the range mask, and get yourself a little preview and bring that into, oh yeah, that's not going to work. Okay, reason won't work because we're not stretched, we're linear, so that won't work. Okay, so let's extract the luminance channel from this galaxy. Okay, don't forget to open screen transfer function, make sure that we're linked down here, open up histogram, choose none. Now let's stretch the luminance channel. There it is. Drag it onto histogram, the bottom bar here. Drag that onto there. That should stretch it quite a bit. Okay, reset. And drag this as a mask. And minimize that. If we did our job right, close this and close this. The star should be pitch white, the galaxy should be pitch white, and the background a nice red. And of course, Control K shows that we have it. Now, if you want to do it properly and you don't want to use keyboard strokes, and some people hate them, and so do I would go to Mask, Invert. Okay, so there's still quite a bit of red. And what that means is quite a bit of red means that's still going to be protected. And I don't really want the background protected here. So I'm going to reopen this. Sorry. Where's my range mask? Sorry, that was it. That wasn't it. Linear transform. Yeah, hold on. Get out of the way. Where's my mask? It's the luminance channel. Oh, right here. Lum. Sorry. Got a little lost. So this white here, we need to darken this if this mask is going to work. So I'm just going to remove the mask. We learn as we go along. Let's take this mask or luminance channel, which we stretched, and go to histogram and select that L for luminance, which is this one here. Okay, and let's, well, I'm going to better bring this back down to 0. Wish there was a reset on that. Okay, let's darken the background of that and just keep the galaxy. That's about it. Because galaxy we want protected. We don't want to protect the background. We're going to do a bit of noise reduction. Let's apply that by dragging the triangle into here. Now let's apply this to here. Drag and drop. Galaxy's still there. Stars are still there. We can prove it like this. This is just, by the way, show, unshow. Now let's go to Mask, Invert. That's a lot better. Now it's not as red down here. Okay, so noise reduction. First, Control K. We don't want to see the red. Let's pick a spot where it's quite noisy. Okay, here it is. Hopefully you can see this. Multi-scale. Let's go with luminance channel, which is also RGB, but noise reduction will have to be very subtle. Very, 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 very subtle. Okay, so even I just chose the one and already it's attacked. Reason 4 is because the 1 should be down to about 35 or 30. Okay, so before, after, you barely see it. Let's go to 2, and this time we'll take it from 3 down to 2. And bring this one down to 30. And already it's starting. I'm just going back and forth, back and forth. You probably don't even see it, but if you're not careful here, it is going to turn into a poster. It's going to posterize the background. So I'm going to go 3 layers on 4. 1, 2, and 3. 3, 2, 1. Maybe 20 here. It doesn't matter. You don't have to be perfect. But this background is starting. Just go before, after, before, after. I don't want it to go any further. I don't want the background falling apart. So I'm going to apply this to the entire galaxy. This is all done before. Drag this on here. This is all done before we stretch the image. At this point, this image is not even stretched. But even there, it makes enough of a difference to just not make it like this is very smooth. Not destroy the image. The other is, and normally it's chromiants that you want to remove, because let me zoom in here. It's actually not that blotchy. A DSLR would be horrible. But if I start using chromiants on here, I might end up doing more damage. We can do a little test. Let's go to chrominance, yeah. And this time 7 layers. I'm gonna have to reset all these. Reset that one. Reset that one. Reset this one. And we're going to keep this here. Remember, do a preview so you can see this little section here. Okay, now we're just going to work on chrominance, which is the blotchy reddish bluish red. So let's go to 1. This one we're going to leave it full. 2, noise reduction full. 3, full. I'm going to go back up here in a moment. As soon as the little wheel stops turning. Okay, back here to 100%, back here to 100%, back here to 100%. Make sure we're still on chrominance. And let's see if the background here goes from a, oh man, it's hard to tell. Sorry, this should have been 3. And this should have been 3. Enter. Let's have a look. Have a look and see if this is. Let me see if I can shrink this even more. Just grab the edges here and bring it all the way in. And look for another spot. Be careful here when you're moving stars around. Before, after, before, after. Oh yeah. So it does deblotch it quite a bit. So again, I'm just going to go Control K, make sure that I'm hiding a good part of the galaxy. And remove some of the chrominance. And we're going to be done here. Because what's after that? Well, we have to stretch it. It's time to adjust the histogram after noise reduction. Just give it a second. This will take a bit. Close. Remove preview. Remove mask. Remove the mask. Okay. Now stretching. My goodness, there's like 3 ways to stretch. Let me just undo it now because we're going to leave it black. There's 3 ways to stretch this image. One is what everybody does. They pull the daylight out of it here, and then they drag and drop that here. Let me reset all of this. And this should be 1. That should be 1. And let's go down to the actual galaxy. So call Cal. That's Luminance Mike. There you go. So we're stuck on the wall. We're just pulling away from the noise floor of the camera with the 2 or 3 minute exposures. So this is good. And now we're going to stretch. Now, here's stretch function number 1. What do? Well, we leave this linked. We stretch the daylight out of it. Pixinsight will go as far as it can and stop before clipping the very, very center here. Just see if we're going to center of a star. About 3,700 out of 4,000. So that's not quite clipped. We drag it down here. That stretches it. And then we drag this on here. And then reset. And now we can reset it here. Green to the back, purple to the front. There is something we can do here if you want to adjust this color. Let's open up. The first thing I do right away usually is I bring that background back to normal. There we go. We don't need this anymore. So even though I let Pixinsight stretch it, I brought it back to a normal, a better background area. There's a bit of blue to the forefront, then it drops off to red, then it's all equal, and green's been pushed to the very rear. So again, before and after. Ooh, my luminance is in the way here. Before, after, before, after. That's pretty good. There's a bit of IFN in the background here, right here. I don't want to lose that, and maybe later we can just pull that up a little bit. See, there's a bit up here, a bit down here. Play with it, drag and drop. Let's pull this down a bit. So reset. Okay, so there's the galaxy with a bit of noise reduction. I'm going to make another little box here around my, just want to look at my stars. They're good. Gotta watch you don't make halos around stars. That could be bad. And a little Holmberg guy here, a little bit bigger. Okay, there he is right here, nice and blue. But that's the right color, which means so far all we've done is on par with what we're supposed to have done. Let's go off to the arms a bit. So nice blue, pulls over a little bit to the yellow in the center, which M81 does. Let's get rid of that. Okay, let's close the RGB. Actually, you know what? At this point, let's go File, Save As. And we don't want to confuse things here, so maybe I'll put down a new folder, Final, because if I don't do that, I'll confuse myself. So open up the Final folder, and it's a FITS file, eh? For some reason, I work with FITS, 32-bit IEEE. I'm going to remove, I'm not going to leave those like that, I guess. Okay, so it's saved. Thank goodness, don't want to lose that. Don't want to lose this little guy. Now, remember I was going to say color, I was going to do color calibration here. Let me just undo this. Whoops. Okay, this is RGB. And just zoom in here. Sorry, that's not going to work. I got to pay attention to my files. This is Luminance. We can remove, get rid of the Luminance channel. It was only used to adjust this, which is, just do that for a second. Okay. I think I have a file hiding down here. Yes, I do. So aggregate, we're going to get rid of that. Delete the aggregation. Just copy. Yes, I'm going to close that too. We don't need that anymore. Bring this up a bit. Okay. There we go. So this is the same as earlier. This is the same one, except instead of color calibration, it's be photometric calibration. Instead of using the background neutralizer and the color calibration, let's use photometrics. I already have it here. Pay attention here. I'm going to move the galaxy over so we can see it as this window comes out, because I want to see what's going on here too. So I got to move this over, move the galaxy over a bit, reopen this up, move some more. Okay. Acquire from image. Well, there's nothing. Okay, well, let's search by coordinate. It is M81, search. Here it is, 955 at plus 69, get, it enters it. Now, I know that Tim's telescope is a William Optics 132 FLT f7, so it's 925. In reality, it's 912, but I'll leave it at 925. And his hypercam is 2.4 microns in color and mono. Now, here's the thing. People are struggling with this all the time. I chose Canada. If you want, you can go Cambridge at Harvard University, but I chose Canada. Try distortion correction, force plate solving, and ignore existing metadata. Metadata. It's like metahumans, but it's metadata. Alright, let's hit this and see what happens here in this process window. It should open up in a few seconds. I'm really interested in what's happening here because it tells me it's downloading the M81 off the server plate. It's going to look at it, extract all the files, and then it's going to look and see what the colors are for that galaxy, which is an average spiral galaxy. And if it shows in green here, the score is 293. You're already on the right track. I can already tell his image scale is 054. It's 912 millimeters focal length. Ari and deck is there. Keep going. Excuse me. There we go. Process finished. And if you see a blue line here, you're pretty well on the right track. Otherwise, you'll get error after error after error, unable to solve. So here, I'm going to real quick. 912 millimeters, 2.4 microns. Arc 054 arc seconds per pixels image scale for the resolution. All of that's good. I'm just going to keep an eye on the galaxy now, which will probably be very, very subtle. Hopefully it doesn't go a crazy color. Has happened. Found 6 stars with invalid positions, so I guess it's going to attempt to correct that. This is going to take up to a couple minutes, but I'll let it run. I don't know how much time we've exhausted so far, so I'm just going to keep going. I mean, both of these galaxies, both types of color calibration are fine. I mean, you can use background newt, color cal, or go right to photometric and let the galaxy turn into a neutralized RGB. I don't think the word is neutralized. We'll just call it RGB calibration. It is what it is, right? It's color calibrated. You want to color calibrate that image. So this is taking quite a bit of time, probably a couple of minutes. This image, this color calibration, I mean photometric, I didn't do, some are going to ask, I didn't do the noise reduction and all that. That wasn't the point. The point is, if you're going to color calibrate before you do some noise reduction in multi-scale, then do it automatically using the software for photometric color calibration, or, that was automatic, do it manually using background plus color plus aggregate. Found 6 stars with invalid positions. It's going to keep fixing this. Okay, so reference, done. Background star balance, done. Extracting background utilization, done. Okay. So we're going to, these are all the stars here and the various colors. Close that. Minimize this out of the way. Actually, I can close that. And what do we have? Let's see what it did. Maximize this. So there's the yellow stars, a couple of yellow stars. Now, there's a couple of ways. One way I like to do, you know how most people might be afraid to stretch their image because they want to hide the errors? In reality, I want to see how bad things are so that I can make them better. You could hide everything, and that's fine. But here's a real-time preview, and I'm going to, again, do a dirty job, and that's going to take saturation, and I'll take it right out. I'm going to add it in. So there's your gradient of the purple on one side and green on the other. But I want to do that on purpose, just to show the lanes are green or bluish, the center's yellow, like it should be. Okay. Close, close. Because we didn't do DBE on here, or automatic background extraction, because we already did it here. Sorry, wrong file. Here, this is all pretty much done for that. So I'm just going to minimize this. I just wanted to show that. In fact, I'm going to send this to Workspace 2. I'm not going to work on that because we're already working on luminance and color. So here's our target. I can unstretch it. You know, there's still data here that could be stretched, but I don't want to because I don't want to hurt the center as much as possible. So all right, let's minimize the color. Let's open up Luminance. So now, because Luminance has no color at all, so we're going to have to do again multilinear transform just to reduce a bit of the noise, and we're going to need to use a mask. This time, again, I use masks once the image is stretched, but how do you extract luminance from luminance? I mean, here's what I mean. Let's have a look at the range mask. The range mask, to me, doesn't work because it's designed after the fact. As soon as I touch this, see what happens here? I mean, I have no control over creating a mask of this. I'm sure there's other ways to create a mask, but I usually do that afterwards. In fact, I normally stretch the image, put a mask, and then work on noise reduction. But this case, some people create a clone. They just do this and then reapply it, and now you have what? The whole galaxy's gone. So that's not going to work. So let's remove the mask from here. What we could do is what I did earlier is darken this a lot. Maybe that's one way. Actually, I'm learning here something new. Let's go back here. Let's check the luminance copy. Yep. Go here. Create this, and let's just protect the galaxy and not the background. Whoa, right about there. Close. Oh, sorry, I want to close this one. Apply. See, this can now be a mask that can be applied to here, like that. Let me see. I don't know if it's going to work or not. Control K. Yeah, just afraid of that. Okay. Well, wait a minute. Mask, remove, drop it back down. Okay. Let's choose a section that could be fairly noisy, which this image is not noisy at all. You know what? I'm not going to apply noise reduction where there's not noise reduction needed. So, lesson learned. Let's open up the luminance copy. Let's get rid of it. Yes, I understand that. And back here, maximize. Okay. I'm going to say what I said to a whole bunch of other people. You have tools in your toolbox. You want to cut a 2x4. What tool are you going to use? Hacksaw, jigsaw, table saw, cut-off saw, miter saw, jigsaw, or a sledgehammer. Pick your tool. In some cases, you pick the proper tool. This image is not really that noisy in the background. If I zoom in, it's not really that noisy. And if it is, we're going to work with it after we do some a little bit of stretching. So let's stretch this image. I'm going to make it like that, but this time I'm going to use Arc Synth, reset, show, and we're going to go to stretch factor about halfway, and then we're going to find the black point. So let's start stretching a bit here, about halfway, estimate black point, and you see all these have been clipped, a little white salt and pepper. Let's back up till they're gone. Gently pull ahead, estimate, back up a bit, just until they disappear. Again, this is one way of stretching. If you don't have Arc Synth, don't worry about it. Use Histogram Transformation. But I really want to pull this until the IFN, this Holmberg guy, and all this dark flux in the galaxy, it stays with us. I can go some more. There it is. Again, if you want to clip and just unclip. right there. That's pretty good. Now watch. Before. Here's this before and after. Before, after. Close, drag and drop to your nice galaxy. And for some reason, when you're in ArcSyn, it always looks much smoother. I mean, they actually drop it here, and it looks like it regained a bit of background speckles. But that's what brings us to the next step, ACDNR. Now, because I've already stretched this, I really want to save this. All right, M81 Loom. Yeah, so let's save it. 754 IEEE. Very good, very good, very good. Move this out of the way. Long process, isn't it? Took about 3 hours to get to where we're going, I suppose. It might not go all the way. I guess you guys know what to do when it comes to doing some. Well, we'll see. Okay, so this is pretty good, but again, a little noise reduction because these two files pretty soon are going to be put together 2 different ways, perhaps 3 different ways. We'll see. And then you can choose whichever way you like. So ACDNR, let's have a look. This one here. Yep. Okay, another little, let's grab a little section. This might be much the noisiest one. Here. That's not bad. Always keep an eye on your stars. In fact, make 2 of them and go down here or something. Because I want to see if the stars are going to be damaged. Okay, let's start with this one. So, the first thing I do, and this is because I just do it quite a bit, but I'm going to go right down the amount. I don't want to go past 60. And this 1.0. Why? Because I don't want to posterize. Now we can leave the rest by default, but hit the preview and then open preview window. Now here's what you want to do. This grayish area can't be gray. It has to be pitch white because that's what you want to attack. So by playing with the sliders, darken the stars and make that background. Keep going until it's almost pure white. There. So before, after, before, after. I don't want to protect a bit of noise. I want to get rid of it. So it has to be white is what we're going to attack. Black is what's going to stay protected. Before, after. Even the galaxies are still showing up. Before, after. That's pretty good. If you uncheck preview down here and recheck lightness up here, right away Pixinsight applies it. Now let's see the before. It's kind of grainy. After. Before, after, before, after. And that's so subtle. I don't want to posterize this image. I don't want to destroy it. I just want it to be soft enough. So if I close this, this is the actual one right here. Let me drag and drop this and I'll undo it. Okay. Oh boy, that's rough. Before, after, subtle, soft, little sandpaper-ish, soft, sandpaper, soft. Okay. I don't mind that, so I'm going to undo, go to the main image. And remember that the preview, the mask is already on there. So let's drag and drop. Because when I selected the mask, it created a mask and put it on top. Even though it doesn't show it here in brown. Oh wow, what a difference. Okay, let's zoom in. The galaxy's smooth. The background's much smoother. The stars haven't been destroyed. There's a galaxy right here. So back out. Back to its normal size. Here. Close ACDNR. You can remove some of these boxes if you want. Choose it or remove it. Let's reopen this up. Make it the same size. Make sure at all times they always match up. Now to me, if I look at this, I say, well, you know what? The background looks purple. It does. What can we do about that? Let's see if we can carefully use the histogram transformation. Go to SoCal, which is right here, and make a preview. This preview. And let me zoom in here. See this blue leading edge? That's what's causing that. Let me zoom out. Ooh, here I'm saying zoom out and I'm zooming in. Okay, there's that blue leading edge. That blue leading edge and the red, that's causing this purple. So if you want, you can go to the red, Watch the red here though. Always watch that, and just subtract a little bit of it, just like that. Before, after, before, after. From here I can see it clearly. It went from purple to a lighter blue. Now go to the blue channel, look at the blue here, and do a bit of redaction there, and whoa, you see what happens here? Well, here, let's exaggerate. There, that's what you don't want, because now it's just left yellow and green. And this is what you don't want, because now it's turned green. So they have to kind of match. There's the blue. There's the red. Let's put the red right on the edge. And let's put the blue. Do you know where I'm looking? I'm looking right here. I'm following this leading edge here. It's now neutralized. So let's go before. Purple, neutral, purple, neutral. Bingo. Can we actually drag that on there? Let's find out. Before I drag that on there, what do you think we should do? I'm asking you a question now. I don't want to affect the galaxy, so I'm going to keep with my settings, right? And now I'm going to make a range mask. Let's just get rid of this. Why? To protect the galaxy from changing color. Let's do a range. Let's just grab the galaxy. A little bit of, oh, back up a bit. Let's feather it like Photoshop. Okay. Let's create that mask, because we're just going to invert it and get rid of that purple. So let's create the mask, and the mask is going to turn out a bit grayish white. I'll show you why and how to fix that. So actually it's not that bad, but it's not good enough. Close range, open up Histo, choose the L for sorry, what is it? Range mask. Okay, go back to all RGB colors, make a preview of this mask, and just make the background, make the galaxy, I should say, whiter. Why? Because we want to protect galaxy. We just want to work on the background here. Close, stretch, or unstretch. Actually, we're darkening it, and add this to your image. And now you should just see the galaxy. See, before, after, and now let's invert it. Go to mask and invert it. Now the galaxy is protected. A little bit of the background is protected, but we can work on that now by going back to, what is it called? RGB Cal. Remember this blue and pink? Let's work on it. This here, though, we can go Control K. And we can pick a section here to look at. Okay, so let's do a preview that's live. There it is. Let's work on red first. Pull it back until we just meet up with the white line. Stop. Blue. Pull it back. I'm sure there's other ways to do this, but look at before. This is all purplish blue. After, neutralized. Yes, there's a bit of, let me zoom out, a bit of green in the background, but I kind of want the green in the background. I don't want it to the foreground. So, and hopefully this will not damage the color of my galaxy. Well, it shouldn't, because I masked most of it. Okay, drag this newly adjusted color, and let's see if this purple goes away and turns a bit neutral. Oh, excellent. Close this. We can get rid of this little red icon in the far back here. Delete preview. Some people go preview, delete all previews. That's fine. It's the same thing. Mask, remove mask. Now what are we going to do with this? Well, I think I can now just go back to the word RGB. Voila. And the range mask, well, I'm going to get rid of it, though you could keep it. Well, here's an idea. See this luminance? Let's do this. Are they both identical? If I drop this on here right now, and I went Control K. Well, you can't go Control K until you select this in blue. Control K. This is on the luminance channel. So technically you could use that, though I am cutting the outer edge here, right? But if you needed to work on just the galaxy's center, that might come in handy. But I won't do that for now. Remove, minimize, close. Yeah, we don't need the mask. Okay, so try to get these, always get these out of order. Luminance Mask, I'm going to save and overwrite Loom. Yes. 32-bit IEEE for this. This one, just going to make sure it's saved in color. Yeah, we're going to remove the SoCal now. just have a look and see what it's called. RGB underscore. Yeah, I'm going to end up with two here. Yeah, go ahead. Okay, let's go have a look. Let's go have a look. Let's go have a look. Finals. Okay, let's see how big these files are. Whoops, my bad. Going too fast. So Cal can go because we just renamed it RGB. So both L-RGB are now there. And there's our galaxy in color, and here it is in black and white. And when I click on it, it's adding a little bit of detail. If I put the luminance up and then put the color over top, there's a lot more galaxy that comes out. And this Holmberg, I think it's called, comes out a little bit more even. Now, how far should we stretch luminance to bring out the rest of the lanes is kind of up to you. I just kind of stay subtle at the moment. The IFN is all there. I can see it now. It might or might not disappear when we combine. So now that we've done that, we're going to also want to sharpen a little bit of the details. Go back to luminance because we're still working on luminance here. We're going to what do we want to do now? I'm just going over my quick notes here. Multi-scale linear transform. We still need to make a range selection mask. Let me see if I can do that. We're going to have to do a new one. So find your range. Hopefully this will work. Make a preview. Always create a nice mask that brings in all the IFN right there. Don't forget to feather it. This is so you don't have a sharp drop off in both. Again, by going to the lower limit, you can almost just get the galaxy, which you don't want that. And if you go too far, well, now you start to get some of this flux that I was talking about. Excuse me. You can probably bring this down because we're going to try to add a bit of sharpness here. Remember, this is kind of new. The smoothness, maybe try 15 here. Here we go. The smoothness maybe a little bit less. Maybe around 5. Remember, this is all new to me. I'm practicing something different here. Okay, and let's apply that mask, and let's see if we can work on the brighter areas. Okay, so make it, and close that. This is a real-time preview. Get rid of this. Okay, make this a bit smaller. And let's drag this mask on the galaxy. Let's just see what we're going to... Okay, so the stars are showing up and the galaxy is showing up. The background's covered, basically. Let's see now if we can use multilinear transform. I'm going about this here. Multiscale linear transform. I'm going to have to reset this. And we'll see if we can sharpen that on bias. See the bias here? Well, first let's create a little window so we see what we're doing. And let's have a look at the preview. I believe this is it. Yeah. Okay, so this is our preview, and if we choose bias detail, we can try. Let's try 050, and let's see. Let's also do Let's also do 2 and 3. 075. Yeah. Let's get off one here for a second. Get rid of one. Okay. So I'm going to put 50 here. You can experiment. 50 and layer 3.
Good. For now, anyways.
Let's try, I'm going to try a lot here. 1.00. Okay, see what happens? So this is why you have to be really, really, really careful on how much here. So 1 is way too much. I'm going to back off to about 40. And this one maybe even more. I'm just watching the galaxy down here. In fact, let's move this. It's just it's kind of another HDR, but there's also some ringing going on here. I don't know if de-ringing would help. If it is, you'd probably have to set the de-ringing values, and I don't like that. That's a bit better. Is there before and after on here, or just before, after, before, after? Yeah, everything here snaps into view. The stars get brighter too. So let's have a look. I'm going to minimize. I'm actually going to close this. I'm going to make this a little bit bigger. Remember, this is to add. I'm going to get rid of this. I don't like when the preview window's in the way. 4 and 2. Let's drag and drop on RGB. This is not RGB. This is actually luminance. Let's try it. Let's see if the galaxy, if we bring in some detail. Yes, but we've included a bit of noise. Now, be careful here when you're using this. This is almost like HDR. Didn't touch the background that much, but boy, did it ever touch the... here, let's do before and after. Remove. After. I'm sure you can see this a little bit closer. Before, after. I don't like how much it destroys the edge, so it was a nice attempt. So I undid it, and if you guys want to play with this bias levels by playing with level 2 and 3, it should, you know, just experiment with these numbers and make sure you're on luminance, because this is luminance. Close. Okay. That was a wasted effort, but it was experimental. Never said that things were perfect, and I'm not good at this. I'm not really an RGB person. What we can try, though, is local histogram equalization. Now, that I've used quite a bit. So let's try, if you want, if some people want to, they're going to want to see, some people want to see what HDR does. Okay, well, we're here. Let's do HDR. It is really hard. I find HDR is pretty hard on the software. So de-ring it 5 and maybe to lightness, and just drop it, drag it, and see what happens to the core of the galaxy. It's really hard on the start. Before, after, before, after. See what happens here? Before, after. I like it, but I don't like the rings around it. Sorry. Let's see if large... Am I on... Yeah. Let's see if we can change large scale de-ringing. Increase it more. Now can we apply it? Not much here. Before. We'll try small scale. Try more large scale and see if that protects the stars. Okay, that's way too much. So back to about 20. This is all experimental. Again, I like what it's doing to all the inner core, but it's damaging my stars. You end up with black circles, and I don't like those. Let's undo, and let's take de-ringing completely off, just for a moment. Yeah, definitely need de-ringing. It is helping. Let's put it back on. Let's increase large scale to really big. Oh, that's a lot better. Okay, so what am I at? 700? Let's try 600. You spend an hour here. I didn't want to do this, but okay, that's acceptable. I mean, the ring-wise, it's acceptable. So a little bit of HDR before we combine L-RGB together. Watch the galaxy. Boom. Not much happened there, eh? Let's undo that. No, not much happened there. Before, after. So that is very strange. Undo HD. Hold on a second. Let me check this. Let's try it again. That should have snapped into view like it did on the small preview, but it doesn't. It actually kind of washed out the image instead. Yeah, nothing happened, eh? Before. Nope. Well, that is very strange. To lightness. Okay. Maybe this will work. I've done this before, but when I'm alone, I experiment. Now I'm trying to just show you how to get through this. So at the end, yeah, this is not working. At least it's not showing up for some reason. Control K. It's turning out really nice in the preview. As you can see here, look at before, after. The lanes are nice and pronounced, but as soon as I go here, nothing seems to happen. Undo ACDR, redo HDR. Well, I'll leave it off. That's all new to me. I've never seen this before. Before, after, before. Let's drop it now, see if it happens. See if it darkens the lanes in the middle and gives us more detail. Hey, for some reason it's washing it out. Nope, that ain't working. I'm gonna hit reset to 5. Let's try this. This is your standard HDR that kind of makes halos around stars. I don't like that. Yeah, much better. But again, I'm hoping that these halos will disappear when the color goes over top. We're hoping for that. That's what we're hoping for. Going back to Loom, get back in RGB. Be careful here with HDR because, man, it may have brought in a lot of the lanes here nicely, but I'm not afraid to mention what it can do. Alright, so I'm just going to pull this off here to the side. That makes a copy. Let's put it down here, way down low. Okay, and I'm going to undo this HDR, and I'm going to go for local histogram transformation, which is another one that kind of acts like it. Let's make a first. Let's just brought this down to 0. Make another copy. We already have a preview. Let's look at the preview. There it is. Kind of big. I also would like to see more of the outer edge, so let's bring it up here. Hey, careful. If your computer's fast, you'll be okay. Okay, so I see the core and I see the outer edge. This is my preview. So I've got amount. I mean, I set my amount to 0, but let's try about 250. Let's put this in 12-bit mode. Let's try 250. 250. Enter. Okay, so before, after, before, after, before, after. Not much going on there. So we're going to have to increase the kernel radius to maybe, let's try 100. Enter. Let's watch the wheelie thing. Oh yeah. These are much better in the, there's a lot more difference in the middle. The contrast limit, you got to be careful because that really makes the outer image noisy. I'm going to show you what can happen here. I'm just going to bring it up to 4. See this? It's subtle, but look at how much it brings all the lanes in, but accentuates the outer rim of the galaxy, which can get a bit noisy, and I don't want to do that. So that's one thing we can do. Let's try back down to less, 1.5 from 2. That should soften it up quite a bit. Oh, much better. But now let's do more amount. So let's try 350. Enter. Before, after, before, after. Oh, it's subtle, but it's there. Kernel radius can probably go even higher. Let's try 125. Enter. Got to be careful with the contrast. The contrast kind of erects the outer edge. Before, after, subtle. Let's try as high as I can go, 150, and then I'll try more amount. Before, after, before, after. It also brings out more of the background INF. Well, I can actually have it. Yeah, I've got that hidden. So again, I just want to bring my little guy here closer to the center. Make sure you don't move because this is going to mess up. Before, after. Yeah, a little bit. Let's try more. Let's try 450. Let's see what she says there. My computer's going to blow up. Okay. Before, after, before, after, before, after. Okay, that's not bad. It's not bad. Let's drag and drop this on the main image and see if we see a bit of a contrast difference here. The limit is a bit low at 1.5. Could have stayed 2 or 2.5, but man, be careful. It starts to break apart the pixels, and we don't want to posterize anything. We certainly don't want to add more noise. Let's see what this does to the main part of the galaxy. This is going to take a while. I will pause. So that finished up. Let's have a look. Yeah. So that was a long process. So those were the settings: 150, 450, 1.5. Play with these to get the galaxy to come out. Because later, when these two are combined, you're going to probably do HDR anyways, because they're not combined right now. So let's close this. Let's go mask heap, remove the mask, move over L, open up RGB, side by side. Look at the difference in sensitivity of the camera. 58% quantum efficiency on the right, just a one-shot color hypercam from Altair Astro. That's the left. On the right, 86% quantum efficiency on the hypercam mono, cooled. So now we're done for part 2. Let's go on to part 3, which will be L-RGB combination in its various forms. Okay, so see you in part 3.